Hello, in this lecture we will find the value of x using two different methods. In the drawing we have right triangle ABC. We know that angle ABD equals to alpha, angle DAE also equals to alpha, and angle EAC also equals to alpha. We also know that dB equals to 3 units, dE equals to 4 units, and we want to find out the value of EC that is actually equals to x. Okay, so first of all I will present to you the angle bisector theorem. So actually, what is the angle bisector theorem? The angle bisector theorem actually, if we have triangle ABC, and we know that AD is angle bisector. That is to say, it bisects angle ABC, or it divides angle BAC to two equal parts. So if this angle is theta, this angle also will be theta. So angle bisector AD divides angle BAC to two equal parts, to theta and theta. Okay, so according to angle bisector theorem, an angle bisector in a triangle divides the side it eats in a ratio that equals to the ratio of the angle legs. So I will read the angle bisector theorem again. The angle bisector theorem states that an angle bisector in a triangle divides the side it eats in a ratio that equals to the ratio of the angle legs. So actually AD is angle bisector in triangle ABC because of the fact that it bisects angle BAC, it bisects this angle, that is to say, it divides this angle BAC, to two equal parts, to theta and theta. Okay, so according to angle bisector theorem, the angle bisector AD divides the side that it eats. Angle bisector AD in triangle ABC eats side BC and divides it in a ratio that equals to BD over DC. Okay, so the ratio that angle bisector AD divides side BC is actually BD over DC. And that ratio equals to the ratio between the angle legs. The angle legs are AB and AC, and the ratio between the angle legs are AB over AC. So the ratio between the angle legs, that is actually AB over AC, is the ratio that angle bisector AD divides side BC, that is to say BD over DC. Again, the ratio that angle bisector AD divides side BC is the ratio of BD over DC. And that ratio equals to the ratio between the angle legs, that is actually AB over AC. So those two ratios are equal to each other. Okay? So we actually can implement the angle bisector theorem in triangle, the right triangle, triangle BDE. So actually in the right triangle, triangle BDE, this right triangle BDE, we know that AD is angle bisector. Again, AD is angle bisector in the right triangle, triangle BDE. AD is angle bisector. Again, in the right triangle, triangle BDE, AD is angle bisector. So why AD is angle bisector in the right triangle, triangle BDE? Because of the fact that it bisects angle BAE, it bisects this angle, or in other words, it divides angle BAE, this angle, to two equal parts, to alpha and alpha. So the angle bisector AD divides this angle to two equal parts, alpha and alpha. Therefore, according to angle bisector theorem, the ratio that angle bisector AD divides BE is BD over DE. and that ratio equals to the ratio between the angle legs, that is to say AB over AE. Again, the ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say to AB over AE. The ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say to AB over AE. Okay? So, what is the value of BD? The value of BD equals to 3 units according to what is given us in the question. And the value of DE equals to 4 units according to what is given us in the question. And it equals to AB over AE. So, in total we got this equality that 3 over 4 equals to AB over AE. Okay, so here, if we define AB as 3K, that is to say, if we define that AB equals to 3K, AB equals to 3K according to our definition. So we will place the value of AB inside this equality in order to get the value of AE. So we get that 3 over 4 equals to AB, and AB is 3K over AE. Okay, and now we will find the value of AE if AB equals to 3K. Here we will multiply this equality by AE, and we will get that k equals to 3 over 4 times AE. Okay? We multiply this equality by AE, and we got that 3k equals to 3 over 4 times AE. Here we will multiply this equality by 4, and we will get that 4 times 3k is 12k equals to 3 times AE. Here we will divide this equality by 3, and we will get that AE equals to 12 over 3 is 4k. So we found out that AE equals to 4k if AB equals to 3k. Again, if AB equals to 3k, we found out that AE must be equal to 4k. Okay, if AB equals to 3k, then AE must be equal to 4k. So we will continue to focus on the right triangle ABE. So on the right triangle ABE, we know that according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. Okay, according to the Pythagoras theorem, in the right triangle, triangle ABE, AB square plus BE square equals to AE square. But according to our definition, AB equals to 3k, so AB square will be equal to 3k square. And what is the value of BE? The value of BE is actually 3 plus 4, that is to say 7. So BE is 7 and BE square will be equal to 7 square. All equals to AE square. We have already found out that AE equals to 4k, so AE square will be equal to 4k square. Okay, in total we got this equality. Here 3k square is 9k square, 7 square is 49, and 4k square is 16k square. So I'll write it down. 9k square plus 7 square is 49 equals to 16k square. Okay, we got this equality. Here we will subtract from this equality 9k square. So 16k square minus 9k square is 7k square equals to 49. Seven k square equals to 49. Here we will divide this equality by 7 and we will get that k square equals to 49 over 7 is 7 equals to 7, yes? 49 over 7 equals to 7. Here we will take a root out of this equality and we will get that k equals to the positive root of 7. K must be positive number because k represents the size of the side of a triangle AB and AE, so it must be a positive number. Therefore k equals to the positive root of 7. So after we found out the value of k, we know that AB equals to 3k. So we can place the value of k, that is actually root 7, inside this equality, and we will get that AB actually equals to 3 times root 7, and we also found that AB equals to 4k. Again, we can place that AE equals to 4k. So we will place the value of k inside this equality and we will get that AE equals to 4 times k, 4 times root 7. K is root 7, so it is 4 times root 7 units. So we found out the values of AB and AE. So in the next step we will focus on the right triangle, right big triangle, triangle ABC. We know that in the right triangle, triangle ABC, tangents 3 alpha equals to BC over AB. Okay, in the right triangle, triangle ABC, we know that tangents 3 alpha equals to BC over AB. But what is the value of BC? The value of BC actually equals to 3 plus 4 is 7 plus x. Again, the value of BC equals to 7 plus x. And we have already found out that the value of AB is 3 times root 7. So in total, we got that the value of tangents 3 alpha is actually 3 plus x over 7 plus x over 3 times root 7. So I will write it down. The value of tangents 3 alpha equals to 7 plus x over 3 times root 7. So in the next step we will focus on the right triangle, triangle ABE. So on the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. Okay, tangents 2 alpha equals to BE over AB. Again, in the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. But what is the value of BE? BE equals to 3 plus 4, that is to say, to 7. So BE equals to 7. And we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangents 2 alpha equals to 3 over the value of tangents 2 alpha equals to 7 over 3 times root 7. So I will write it down. The value of tangents 2 alpha equals to 7 over 3 times root 7. Okay. So in the next step we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, on the right triangle, triangle ABD. This right triangle, triangle ABD. We know that on the right triangle, triangle ABD, tangents alpha equals to BD over AB. Again, tangents alpha equals to BD over AB. Again, on the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. But what is the value of BD? BD equals to 3 units according to what is given us the question. and AB equals to 3 times root 7. So in total we got the value of tangent alpha equals to 3 over 3 times root 7. So I will write it down. The value of tangent alpha equals to 3 over 3 times root 7. So we actually found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. Okay, so in the next, but we have already know that tangent 3 alpha is actually equals to tangent 2 alpha plus alpha. Tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, I will present to you a new trigonometric identity. The trigonometric identity is tangent A plus B. It equals to tangent A plus tangent B over 1 minus tangent A times tangent B. Again, the value of tangent A plus B is actually tangent A plus tangent B over 1 minus tangent A times tangent B. So we will use this trigonometric identity in order to find out the value of tangent 2 alpha plus alpha. So according to this trigonometric identity, the value of tangent 2 alpha plus alpha, that is actually tangent 3 alpha, will be equal to tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha minus tangent 2 alpha times tangent alpha. Okay, the value of tangent 2 alpha plus alpha is tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha according to this trigonometric identity. Okay, but we have already found out the values of tangent alpha. We also found out the value of tangent 2 alpha and the value of tangent 3 alpha. So we can substitute the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha in this equality by those values that we found out for tangent alpha, tangent 2 alpha, and tangent 3 alpha. So actually tangent 3 alpha, according to what we have already found out, is equal to 7 plus x over 3 times root 7. It equals to tangent 2 alpha. We have already found out that the value of tangent 2 alpha is 7 over 3 times root 7 plus tangent alpha. We have already found out that tangent alpha is actually 3 over 3 times root 7, all divided by 1 minus tangent 2 alpha, that is actually 7 over 3 times root 7 times 3 over 3 times root 7. Okay, so we substituted the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha by the values that we have already found out on those equalities. Okay? And we got this equality. So here we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7 in order to have a common factor with this expression, and we will get that 7 plus x over 3 times root 7 equals to, here we have 7 plus 3 is 10. 10 over 3 times root 7, all divided by, so as I already said, we will substitute the value of 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. Okay, so we substituted 1 by this expression. This expression, as you can see, equals to 1. Okay, and what we have here, we have here minus 7 times 3 is 21. So it is minus 21. So in total we got this equality. So here we will move this expression to the numerator, and we will move this expression to the denominator here, and we will get that seven plus x over 3 times root 7 equals to 10 times 3 times root 7 times 3 times root 7, all divided by 3 times root 7. We will move this expression to the denominator here. We will get that 3 times root 7 times 3 times root 7 minus 21. Okay, so we got this equality. So here we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator. So 3 times root 7 will get cancelled, and 10 times 3 is 30. So what is left after we cancel 3 times root 7? So after we cancel 3 times root 7, what is left is actually 7 plus x over 3 times root 7 equals to 10 times 3 is 30 times root 7, all divided by, here 3 times 3 is 9, and root 7 times root 7 is 7, and 9 times 7 is 63 minus 21. So in total this is the expression that we got. So here 63 minus 21 is 42, so I'll write it down. We got that 7 plus x over 3 times root 7 equals to 30 times root 7 over 42. Okay. Okay, we got this equality. So here we will multiply this equality by 3 times root 7, and we will get that 7 plus x equals to 3 times root 7 times 30 times root 7 over 42. Okay, so here 3 times 30 is 90, root 7 times root 7 is 7, and 90 times 7 is 630. 630 over 42 equals to 7 plus x. So here 630 over 42 is 15, and 15 equals to 7 plus x. So here we will subtract 7 from this equality, and we will get that x equals to 15 minus 7 is 8. So x equals to 8 units. Okay, so we found out that the value of x is actually 8 units. EC that equals to x equals to 8 units. Okay, so we finished with the first method. So in the next step I will present to you the second method to find x. So in the second method we will extend BD by 3 units. And we will define this point as point M. We extended BD by 3 units, so MB will be equal to 3. Okay? Then we will join together points A and M by a straight line. So we extended BD by 3 units, so BD is the side of the right triangle, triangle ABD, therefore it is a straight line, and after we extended BD by 3 units, BM will remain a straight, MB will remain a straight line, therefore actually MB is a straight line. Okay? MB is a straight line because BD is the side of the triangle that is a straight line, and we extended BD by 3 units, so MD will remain a straight line. So you can write down that MD is a straight line. Okay, MD is a straight line, and we actually have a rule that states that The rule states that the sum of the angles on a straight line is equal to 180 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. So actually the sum of the angles on the straight line MD must be equal to 180 degrees. So at any point on the straight line MD, the sum of the angles must be equal to 180 degrees according to this rule. So if we focus at point B, the sum of the angles on the straight line MD must be equal to 180 degrees. So which angles we have at point B? At point B on the straight line MD we have this right angle, angle ABD is a right angle according to what is given us the question here. So we have at point B 90 degrees, and we also have this angle, angle ABM, plus angle ABM must be equal to 180 degrees according to this rule. So here we will subtract 90 degrees from this equality, and we will get that angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle ABM is a right angle, that is to say it equals to 90 degrees. Okay, so in the next step we'll focus on those two right triangles, triangle ABM and the right triangle ABD. So on the right triangles, triangle ABD and triangle ABM, we know that BD equals to BM equals to 4 units, okay? BD equals to BM okay, BD equals to BM equals to 3 units. BD equals to 3 units according to what is given as the question, and BM equals to 3 units. This is according to our construction. So BD equals to BM equals to 3 units. And we also know that those two angles are equal to each other. Both those two angles are right angles. So angle ABD equals to angle ABM, and both those two angles are equal to 90 degrees. Okay, we proved that this angle equals to 90 degrees, so angle ABD equals to angle ABM equals to 90 degrees, angle ABD equals to 90 degrees according to what is given us in the question, and angle ABM equals to 90 degrees according to our construction. And we also know that AB equals to AB. That is to say, AB is a common side. It belongs to both triangles. So AB equals to AB. It is a common side. Again, AB equals to AB, it is a common side, it belongs to both triangles ABD and triangle ABM. So we actually proved that triangle ABD can go into triangle ABM according to side angle side rule. So I write it down. We proved that triangle ABD congruent, this is the sign of congruent, to triangle ABM according to side angle side rule. Okay, so what is side angle side rule? Actually, if you prove that two sides and the angle between them in one triangle are equal to two sides and the angle between them in another triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved that in the right triangle ABD, we have side AB and BD and the angle between them that are equal to MB and AB in the right triangle and the angle between them in the right triangle ABM. So we actually proved that those two triangles can go into each other according to side angle side rule. Okay, so from the fact that those two triangles can go into each other, actually we know that here, according to what is given us in the question, those angles are all equal to alpha. So from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other. That is to say, angle BMD angle BAD equals to angle MAB again, angle BAD equals to angle MAB according to the rule that corresponding angles in congruent triangles are equal to each other. Corresponding angles in congruent triangles are equal to each other. I repeat again, angle BAD equals to angle MAB according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding angles, those two corresponding angles will be also equal to each other. And we know that angle BAD equals to alpha. Angle BAD equals to alpha. So from this equality we can derive that angle MAB also equals to alpha. Okay, so angle MAB also equals to alpha. And from the fact that those two triangles can point to each other, we can conclude that side AM equals to side AD. side AM of triangle ABM equals to side AD of the right triangle, triangle ABD. AM equals to AD, AM equals to AD, according to the rule that corresponding sides in congruent triangles are equal to each other. Corresponding sides in congruent triangles are equal to each other. Again, side AM of triangle AMB equals to side AD of triangle ABD, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say AM and AD, will be also equal to each other. Okay, and if we define AM as Y, if AM equals to Y, then from this equality we can derive that AD also will be equal to Y. So if AM equals to Y, then AD must be also equal to Y. Okay, so in the next step we will focus on triangle ADC, on triangle ADC. Okay, so in triangle ADC, we know that AE is angle bisector. Again, on triangle ADC, this triangle AE is angle bisector. On triangle ADC, AE is angle bisector. Okay, so YAE is angle bisector on triangle ADC because of the fact that AE divides angle DAC, this angle, to two equal parts, alpha and alpha, or AE, angle bisector AE, bisects angle DAC. Okay, it divides angle DAC to two equal parts, alpha and alpha, therefore AE, the angle bisector AE, for that reason, it is defined as angle bisector. Okay, so according to the rule to the angle bisector theorem, the ratio that angle bisector AE divides DC is DE over AC. Again, the ratio that angle bisector AE divides side DC is DE over EC, and that ratio equals to the ratio between the angle legs, that is to say to AD over AC. AD over AC I will repeat again, the ratio that angle bisector AE divides side DC of triangle ADC is DE over EC, and that ratio equals to the ratio between the angle legs, that is actually AD over AC. AD over AC is the ratio between this angle legs. Okay, and those two ratios are equal to each other. But what is what is the value of DE? DE equals to 4 units according to what is given us the question, and what is the value of EC? EC equals to X. What is the value of AD? AD equals to Y. So in total, in equation number 1, we got that 4 over x equals to y over AC. Here we will multiply equation number 1 by AC, and we will get that 4 over x times AC equals to y. Here we will multiply equation number 1 by x, and we will get that 4 times AC equals to y times x. Okay, so here we will divide equation number 1 by 4 in order to get the value of AC, and we will get that AC according to equation number 1 equals to y times x over 4. So we actually found out the value of AC according to equation number 1, AC equals to y times x over 4. So in the next step we will focus on the big triangle AMC. On the big triangle AMC, we know that AD is angle bisector. AD is angle bisector on the big triangle AMC. Again, AD is angle bisector on the big triangle AMC. So why AD is angle bisector in the big triangle AMC? Because of the fact that AD divides angle MAC to 2 equal parts. It divides this angle to 2 equal parts. This part is 2 alpha, and the second part is also 2 alpha. Again, the first part is 2 alpha, and the second part is also 2 alpha. So because of the fact that angle bisector AD divides this angle MAC to 2 equal parts, for that reason AD is defined as angle bisector in triangle AMC. Okay, and according to angle bisector theorem, the angle bisector AD divides side MC of triangle MAC in a ratio of MD over DC. MD over DC is the ratio that angle bisector AD divides side MC. Okay, again, MD over DC is the ratio that angle bisector AD divides side MC of triangle AMC. And that ratio equals to the ratio between the angle legs according to angle bisector theorem. So the ratio that angle bisector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is actually AM over AC. Okay, AM over AC. Again, the ratio that angle bisector AD divides side MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is to say AM over AC. Okay? The ratio that angle resector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is to say to AM over AC. But what is the value of MD? The value of MD is actually 3 plus 3, that is to say 6. And what is the value of DC? The value of DC is 4 plus X. The value of DC is 4 plus X. And what is the value of AM? The value of AM is Y. So in total, we got equation number 2 that states that 6 over 4 plus x equals to y over AC. Here we will multiply equation number 2 by AC, and we will get that six over 4 times x equals to y. So we multiplied this equation by AC, and we got that AC times 6 over 4 plus x equals to y. Here we will multiply this equation by 4 plus x, and we will get that 6 times AC equals to y times 4 plus x. So here we will divide equation number 2 by 6 in order to get the value of AC. So AC according to equation number 2 equals to y times 4 plus x over 6. Okay, we found out the value of AC according to equation number 2. It equals to y times 4 plus x over 6. And we already found out that the value of AC according to equation number 1 is actually y times x over 4. So we actually got the value of AC according to equation number 1 and according to equation number 2. In the next step we will create equation number 3 that states that AC equals to AC. Okay, so we created equation number 3 that states that AC equals to AC. So in this equality we will place the value of AC from equation number 1 in this side of the equality, and we will place the value of AC from equation number 2 in this side of the equality of the equation, and we will get that the value of AC according to equation number 1 is y times x over 4, and the value of AC according to equation number 2 is y times 4 plus x over 6. So we got this equation number 3. Here we will divide equation number 3 by y. Actually, it is allowable to divide equation number 3 by y because y can never be 0. Y is actually the size of side AM and the size of side AD of a triangle. Therefore, it must be a positive number. It can never be 0, so it is allowable to divide equation number 3 by y. After we divide equation 3 by y, we will get that x over 4 equals to 4 plus x over 6. So here we will multiply equation number 3 by 4 and 6, and we will get that 6x equals to 4 times 4 plus x. So we will open the brackets here, and we will get that 6x equals to 4 plus 4, 4 times 4 is 16, 4 plus x is 4x. So here we will subtract 4x from equation number 3, and we will get that 6x minus 4x is 2x equals to 16. So here we will divide equation number 3 by 2, and we will get that x equals to 8. So we found out that x equals to 8 units according to the second method. X equals to 8 units. Okay, so we can write here that the value of EC that equals to x is 8 units. Again, the value of EC that is actually equals to x is 8 units. Okay, so we finished with the second method. So in the next step I will summarize the lecture. Okay, so actually in the first method I wanted to find out the value of x, of EC that equals to x, and we actually know that BD equals to 4 units, DE equals to 4 units. Those angles are equal to alpha, and angle ABD is a right angle, therefore triangle ABC is a right triangle, and we want to find out the value of EC that equals to x. So in order to find out the value of x, I presented to you the angle bisector theorem. The angle bisector theorem states that angle bisector in a triangle divides the side it eats in a ratio that equals to the ratio of the angle legs. So AD is angle bisector in triangle ABC because of the fact that it divides angle BAC to 2 equal parts, to theta and theta. Therefore AD is angle bisector in triangle BAC, in triangle ABC, and according to angle bisector theorem, the angle bisector AD divides the side that it eats. AD eats side BC and divides it in a ratio that equals to BD over DC, and that ratio equals to the ratio between the angle legs, and the angle legs are AB and AC, so the ratio between the angle legs is AB over AC again. So the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is actually AB over AC. Okay, so those two ratios are equal to each other. That is to say BD over DC equals to AB over AC. So that is the angle bisector theorem. We implemented the angle bisector theorem in our drawing in the right triangle ABE, we know that AD is angle bisector. Why AD is angle bisector in the right triangle ABE? Because of the fact that AD divides angle BAE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle BAE. And according to angle bisector theorem, the angle bisector AD divides side BE in a ratio of BD over DE. Again, the angle bisector AD divides side BE in a ratio of BD over DE. And that ratio equals to the ratio between the angle side, the angle legs, according to angle bisector theorem, that is to say to AB over AE. AB over AE. Again, the ratio that angle bisector AD in triangle ABE divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say to AB over AE. And what is the value of BD? BD equals to 3 units according to what is given us in the question. And what is the size of DE? DE equals to 4 units according to what is given us in the question. So BD over DE is actually 3 over 4, that equals to AB over AE. So we got the equality that 3 over 4 equals to AB over AE. Then we defined AB as 3K, that is to say AB equals to 3K, and then we placed the value of AB inside this equality, and we got that 3 over 4 equals to 3K over AE. We placed inside AB the value of AB, that is actually 3K, and we got this equality. And we found that if AB equals to 3K according to our definition, then AE must be equal to 4K. So we found that AE equals to 4K if AB equals to 3K. Then we continue to focus on the right triangle ABE. On the right triangle ABE, according to the Pythagoras theorem, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square must be equal to AE square according to the Pythagoras theorem. Again, in the right triangle ABE, AB square plus BE square must be equal to AE square. But AB equals to 3K according to our definition. And what is the value of BE? BE actually equals to 3 plus 4, that is to say to 7. So BE equals to 7 and BE square equals to 7 square. And AE equals to 4K according to what we have already found. So AE square will be equal to 4K square. Okay, so we opened the brackets here, and we got that 4K square equals to 7 square is 49, and 4K square is 16K square. Okay, 3K square is 9K square, 7 square is 49, and 4K square is 16K square. Okay, so we solved the simple equality, and we got that the value of K is the positive root of 7. So if AB equals to 3K and K equals to root 7, so we can place the value of K inside this equality. We found that AB equals to 3 times root 7, and we know that A equals to 4K, and again we can place the value of K inside this equality. We placed the value of K inside this equality, and we found that AE equals to 4 times root 7. So we have the value of AB and the value of AE. Okay. Then we focused on the right triangle ABC. We know that in the right triangle ABC, tangents 3 alpha equals to BC over AB. Tangent 3 alpha equals to BC over AB. What is the value of BC? The value of BC equals to 3 plus 4, that is 7, plus x. So the value of BC is 7 plus x. And the value of AB, we have already found out that is 3 times root 7. So in total we got that the value of tangent 3 alpha is 3 plus x over, the value of tangent 3 alpha is 7 plus x over 3 times root 7. Then we focused on the right triangle, triangle ABE. We know that in the right triangle, triangle ABE, tangent 2 alpha equals to BE over AB. Again, in the right triangle, triangle ABE, we know that tangent 2 alpha equals to BE over AB. But what is the value of BE? BE equals to 3 plus 4, that is to say 7. So BE equals to 7, and we already found out that AB equals to 3 times root 7. So in total we got that the value of tangent 2 alpha equals to 7 over 3 times root 7. Then we focused on the right triangle, triangle ABD. This triangle, we know that in this triangle, tangent alpha equals to BD over AB. Tangent alpha equals to BD over AB. But we know that BD equals to 3 units according to what is given us in the question. Okay, so we get that BD over AB is actually 3 over 3 times root 7, because we already found out that AB equals to 3 times root 7. So in total we got that tangent alpha equals to 3 over 3 times root 7. So we found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. Okay, and we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha, and in order to find out the value of tangent 2 alpha plus alpha, I presented to you a new trigonometric identity that states that tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A plus tangent B. So we calculated the value of tangent 2 alpha plus alpha according to this trigonometric identity, and we found out the value of tangent 2 alpha plus alpha according to this trigonometric identity equals to tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha. But we know the values, we have already found out the values of tangent 3 alpha, tangent 2 alpha, and tangent alpha, so we can place the values that we have already found out for tangent alpha, tangent 2 alpha, and tangent 3 alpha in this equality. Okay, so we place the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha in this equality, and we got this equality. We actually solved this equality. There is only one variable that is missing, that is x. After we solved this equality, we actually found out that the value of x is actually 8 units. So the value of EC that is actually x is 8 units. Okay, so that was the first method to find out the value of x. Then we found out the value of x according to the second method. Actually, in the second method, we made a construction. We extended BD by 3 units, and we defined this point as point M. So actually MB equals to 3 units because we extended BD by 3 units, therefore MB equals to 3 units. Then we joined together points M and A by a straight line. So here we extended BD by 3 units, and BD is the side of the triangle, therefore BD is a straight line, and after we extended it by 3 units, it remains a straight line, therefore MD is a straight line. Okay, MD is a straight line, and we have the rule that states that the sum of the angles on a straight line equals to 180 degrees. And especially on the straight line MD, the sum of the angles at point B on the straight line MD must be equal to 180 degrees. So which angles we have at point B on the straight line MD? We have here angle that equals to 90 degrees according to what is given us in the question. Angle ABD equals to 90 degrees plus this angle plus the size of angle ABM must be equal to 180 degrees according to this rule. So 90 degrees plus the size of angle ABM must be equal to 180 degrees. Here we subtracted 90 degrees from this equality and we found out that the size of angle ABM equals to 180 degrees minus 90 degrees, that is to say to 90 degrees. Okay, so angle ABM is a right angle, it equals to 90 degrees. So then we proved that those two triangles can go into each other. So first of all, so we proved that the right triangle ABD can go into the right triangle ABM. First of all, we know that BD equals to BM equals to 3 units according to our construction. BD equals to BM equals to 3 units. BD equals to 3 units according to what is given us in the question. BM equals to 3 units according to our construction. So BD equals to BM equals to 3 units. We also know that those two angles are equal to each other. They are both equals to 90 degrees. Angle ABD equals to angle ABM equals to 90 degrees. We have already proved that this angle equals to 90 degrees, so those two angles are both right angles, they are equal to each other. And we also know that AB equals to AB. AB is a common side, it belongs to both triangles. So AB equals to AB as a common side. So we actually proved that triangle BABD is congruent to triangle ABM according to side angle side rule. So what is side angle side rule? If you prove that two sides and the angle between them in one triangle are equal to two sides and the angle between them on the other triangle, you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved that those two sides and the angle between them on the right triangle ABD are equal to those two sides and the angle between them on the right triangle ABM. Therefore we proved that those two triangles can go into each other according to side angle side rule. Then from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, those two corresponding angles must be also equal to each other. And we know that this angle is alpha, so angle BAD equals to alpha, and from this equality we can derive that angle BMAB also equals to alpha. This angle also equals to alpha, and from the fact that those two triangles can go into each other, we can conclude that AM in triangle AB equals to AD in triangle ABD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides that are AM and AD must be also equal to each other. And if we define AM as Y, then AD must be also equal to Y. If AM equals to Y, then according to this equality, AD will be also equal to Y. So AM equals to Y and AD also equals to Y. Then we focused on the triangle ADC. On triangle ADC, we know that AE is angle bisector. Why AE is angle bisector on triangle ADC? Because of the fact that AE divides angle DAC to two equal parts, alpha and alpha. Therefore, AE is the angle bisector on triangle ADC, and according to angle bisector theorem, the angle bisector AE divides side DC in a ratio that equals to DE over DC. Angle bisector AE divides side DC in a ratio that equals to DE over EC, and that ratio equals to the ratio between the angle sides, that is to say to AD over AC. AD over AC. So those two ratios are equal to each other. The ratio that angle bisector AE divides side DC is DE over EC, and that ratio equals to the ratio between the angle legs, that is to say to AD over AC. Okay, and what is the value of DE? DE equals to 4. What is the value of EC? EC equals to X, and AD equals to Y. So in total we got that 4 over X equals to Y over AC. If we multiply the equation number 1 by AC, and we got this equation after this we multiply the equation number 1 by X, and we got this equation, and we divide this equation by 4, and we got the value of AC according to equation number 1 equals to Y times X over 4. Okay, then we focused on triangle AMC. On the big triangle AMC, we know that AD is angle bisector. Why AD is angle bisector? Because of the fact that it bisects angle MAC. That is to say, AD divides angle MAC, this angle, to two equal parts. The first part is 2 alpha, and the second part is also 2 alpha. Therefore, AD is angle bisector on triangle, the big triangle MAC. Okay, AD is angle bisector on the big triangle MAC, and according to the angle bisector theorem, the ratio that angle bisector AD divides MC is MD over DC. MD over DC, and that ratio equals to the ratio between the angle legs, that is to say to AM over AC. AM over AC, so those two ratios are equal to each other. The ratio that angle bisector MC divides, the ratio that angle bisector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is to say to AM over AC. But what is the value of MD? The value of MD is 3 plus 3, that is to say 6. What is the value of DC? DC equals to 4 plus X. And what is the value of AM? AM equals to Y. So in total we got that this equation number 2, and we solved equation number 2. We found that AC, from this equation number 2, we found that the value of AC equals to Y times 4 plus X over 6, and according to equation number 1, AC equals to Y times X over 4. Okay, so we have the value of AC in equation number 1 and equation number 2. Then we created equation number 3 that states that AC equals to AC, and we place the value of AC in this side of the equality. We placed the value of AC from equation number 1 in this side of the equality, and we placed the value of AC from equation number 2 on this side of the equality, and we got this expression. We solved this expression, and we found out that the value of X equals to 8 units. So we found out that the value of X equals to 8 units, EC that equals to X equals to 8 units. So we actually found in both methods, in the first method and also in the second method, that the value of EC that equals to X is 8 units. Okay? So the final answer to the question is that the value of X is 8 units. Okay? Thank you very much.